Hi guys. I'm going to be doing a video here, kind of it's a request, and what it has to do with is looking at this, an isolation transformer, and how to test them. So what I'm going to do is show you some things here, and then we'll go into showing you how to test one. But what we got here is we got that radio I had on here from the last video, and being it is a transformerless radio, we would be using an isolation transformer with it, and it's connected through the isolation transformer through the Variac. I always just keep my Variac plugged into the isolation transformer and then just plug into it. So let's set up a scenario. You've seen, a video of mine or someone else's or something out there, and they tell you that, safety wise, and you're going to work with on these radios and TVs and stuff, some of them don't have transformers. So for your own safety, get an isolation transformer. So you go on eBay and you look up one and you find one, and say it's one that the guy on there says, hey, I've tested it, it works good, it is safe, everything's great about it, it is in good shape, great shape, blah blah blah, the whole spiel. And so you buy it and pay the shipping and wait a week or whatever for it to get there, and you get the darn thing. And maybe you have a All-American 5 radio or something that don't have a transformer, and you decide, well, now I can work on it, and maybe for some odd reason you just want to check it and test it, just for whatever reason. So you get it all hooked up and plugged in, and you got a nice little meter like this, a digital meter, 10 meg ohm input impedance. And so you decide, you think to yourself, well, how am I going to test this? Well, what's it isolating? Well, it's isolating the line where it's plugged into, your house wiring, from the radio where you plug, from that side where you plug the radio into. So I should be able to connect one side of my meter, which we have, to the radio, or to one point on the radio. In this case, we are connected right here at this point here, and if you actually follow out the wiring, it goes to the switch through and then hooks to one. Of course, the other side of the switch is hooked to one side of the power cord. And I want to compare that and look at that as opposed to something somewhere else on my main line. Well, what's the best place to test? How about ground? Because what am I actually doing here? Why is an isolation transformer safe? Well, the main reason is if it was a hot chassis, there's a point, depending on how it's wired or how the plug's plugged in, that the chassis itself could be hooked to the hot side of the outlet, okay, without an isolation transformer. And if my feet or some part of my body is touching earth ground, then I could get electrocuted. So we can check ground or we can check neutral. So let's get a read on this isolation transformer. Right now it's just kind of floating in there, because voltage in the air. We'll go to neutral first. Whoa, hold it. 85 volts. Let's try ground. Yeah, if I can get a hook onto it. One other way to get a hook onto it is 59, 58 volts. Neutral is 85. Now it's 58. And ground is 58 volts. 58 volts with unlimited current is enough that it could hurt me. Well, there's something wrong with the isolation transformer. That idiot sold me a bad isolation transformer. I'm going to run in there right now and get on the computer, and I'm going to give him a bad rating. The worst I can. And I'm going to write up a spiel about how he's selling junk. Well, before you do that, watch my video here. Now, we use 10 megs input impedance, and we got 58 to 80 volts, somewhere in there. In fact, I can actually go to the hot side. I got 70 volts. What's going on? Well, I can assure you the isolation transformer is good. Let's try a different meter. This has got 10 meg ohm input impedance, so it only loads the circuit by 10 meg ohms. It's just like a 10 meg resistor. So let's shut it off for right this moment, and let's look at another meter here. And what I'm doing is I'm connecting. This is hooked to the house current, so I'm going and checking each one of these points. And ground, even though it's it's kind of hard to reach, so I generally just go to the tip of the soldering iron. It's ESD safe soldering iron, which means this tip is grounded. It's connected to the ground, so I can actually check there if I want to check ground. So anyway, to give you some idea what I'm doing here, and we're going to kind of zoom in on this meter a little bit. Hopefully you can see it. Okay, now I'm going to turn this up. There's 10 volts, there's 50 volts. Let's go to 250. One thing to notice on this meter, it's not 10 megs. It's the VOM. It's 1,000 ohms per volt on AC. And I'm on AC because that's what I'm checking. So what that means is whatever scale I'm set on, I take 1,000 ohms times that. Well, 250 volt scale, 1,000 ohms, is just 250 times 1,000. Okay, so that's going to be quite high. It's going to be 2.5 megs. But as I go down, and I will be doing that, I'll go to 50, then 10, and then down to 2.5 volt scale. And at 2.5 volt scale, now the meter's only 2.5 K. It just acts like a 2.5 K resistor. So we'll start at 250 volt scale, and you watch that meter. And as soon as I got so many leads over here, as soon as I make sure I know which lead I've got. Okay, let's see what it reads. Again, we'll check neutral. Wow, not much there on neutral. Let's just look at the hot side and see if it. Nope, doesn't move any. Let's check ground. About the same. So we went from 10 megs, and granted it was like 58, 60 volts, to 2.5 meg impedance. We're on the 250 volt scale. That's right here. We go down. We're under 50. We're under 25. We're down there, what, about 10 volts? That's what, there's a difference in the meters. One's saying almost 60 and the one's saying around 10 volts. Well, if that's the case, if it's 10 volts, I should be able to get it to go up higher by going down. Very little movement. Now we're on the 50 volt scale. 50 volt scale. Well, there's 10 volts. It's not going up there. There's 5 volts. Gee, what is it? Oh, it's about 2 volts. Huh, that's weird. Let's go to the 10 volt scale. That's right here. just below that 50. 10, 8, 6, 4, 2, 1. Less than a half a volt. Well, now, is there something wrong with the meter? Who knows? Let's go to the 2.5 volt scale. You use the 250 volt scale, but you just put 2.5 there, 2 volts, 1.5, 1 volt, half a volt, quarter of a volt. Well, maybe about 150 millivolts, 0.15 volts. So what's the deal? Well, the deal is simply this. The isolation transformer is doing its job, and it's working. It's isolating. But when I put a 10 megohm meter on it, it doesn't load the circuit very much, and at that point this thing is radiating out energy. The outlet radiates out energy. It's AC. Even though it's 60 cycles, it's still an AC transmitter antenna, and that's what the meter is actually picking up. That's what it's seeing. To get really in depth in transformer theory is the fact that when the primary is building and having a changing field in it, it introduces into the secondary. As that secondary starts building up voltage in it, it returns a field too. It starts having a changing field that counters the first field. These countering fields and stuff that's going on in here and messing around will radiate out and will induce a very, 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 and I mean really very, we're talking in the picoamp range currents into other wiring. So on a level of nanoamps and picoamps, way, way down there, there is some, due to those fields, there is some non-isolation going on. And a 10 megohm or even 11 megohm or some high input impedance meter will pick up on that, and you'll actually think you got leakage. You really don't. You don't have any problems. This meter at 1,000 ohms per volt, it loads the circuit enough. And to give you some even better idea, let's look at something else. And we'll rotate here. We're going to look at that light bulb. Now, to give you some idea what that light bulb is, this is a small dial light bulb. It's not even a 100 volt or 110 or 120 volt light bulb by any means. This is a 8 volt light bulb. Now, I got one end connected into my same place as the meters are connected to ground, right on this grounding loop, which has a wire going up. One side of the light bulb's there. The other side we're going to take and is hooked to this probe right here. Now we're going to punch that in there and let's see if the light bulb lights. Wow, nothing. Nothing. Even to ground. Again, ground. Nothing. Now, I want to show you something else. The light's loading the circuit. Now let's take our meter here and get the probe up here, which fell on the floor, and let's just plug it back in where it was reading something. 71 volts. Now we got the light. Let's hook it right to it. Whoa, what happened? What happened was now I'm loading it. This was 10 megohms. This is like 13 ohms. I'm really loading it down. So 13 ohms in parallel with 10 megs, just basically 13 ohms. The meter drops to virtually almost zero. Okay. So if I really want to test an isolation transformer and give you some idea that the radio is on.
One of your former teammates, Manny Ramirez, also now a part.
It's on. So, if I really want to test an isolation transformer, how do I test it? Well, let me shut it off and I'll show you how to test it. First, we're going to unplug it because we don't want no power on it at all. And we'll turn it back on, but now there's no power. And I'll show you the proper way of testing one. Now we can use our meter here. And what we're going to do is we're going to use resistance. And now what we're going to do is a nice thing about, well, you know, any isolation transformer, but this one here, it just makes it easy. I don't even have to go for the cord. And let me unplug it. Let's see if I can draw it out here. Got enough cord. I lift it up this way. Now, if you look here, it says direct. Right along there, let me turn this down just a little bit. And let's get some rotation here. Okay. That says direct on it. What that means is this side, this is the primary side. This is connected in the primary and it's connected to the cord coming in that you plug into the wall. This side is the isolated side. So what I can do is I can take my meter and measure here between all these and see if I get a reading on each side of this. And then I'll show you what's going on here. But this is how you test one. Now we'll bring it down where you can see the meter, and no resistance. Now see, I'm just connected from the isolated the two to the other side, and I can flip between those. You know, I can flip between those connections. I can flip here, nothing. I can flip here and nothing. And then get that stuck in there. I can take it to the ground and nothing, and I'm in ground here, the center prong. So no reading whatsoever. Now what am I doing? I kind of drew up something real quick, and I'll draw something up here real quick, not on the whiteboard because I have to turn the bench off, so hopefully this will be seen. Now this one's a little more sophisticated isolation transformer, being it's got like several different switch positions and things of that nature, as well as if you look at it, it's got low, medium, and high on both sides, and then you got the different positions. So it is an isolation transformer, yes, but it's got several taps on the primary and the secondary to give you those different things. So what we're going to do is we're not going to draw that one out, but we're just going to draw a regular isolation transformer. And this works for any transformer. Okay, now what I was doing with the meter is I'm connecting, say right here, going up to my ohm meter, ohmage, not AC, and going down here. Alright, now on the isolation transformer we got a 3-wire plug, and that third wire is going right here. It's the ground that hooks to the core and to some of the metal casing and stuff. But that's what I'm doing. And then I switched from there, and I went over to here, and I took this one over to here, and then I went from here to here. So I'm going like this, like this, like this. And then I decided to go this way to here and to here. And what that showed was there's no shorts. There's no shorts between this winding and the core. There's no short between, say, this winding and this winding. There's no short between this winding and the core. So there's no shorts. Nothing is shorted. So the isolation transformer is good. It is electrically isolated. There's no connection. Now, if this was shorted across, say, right to here, somehow, then when I took the meter and went like this, it would have read. It read some sort of resistance, or even almost zero, depending on where that short is. Same way with this one. If it was like that, then we would have got a reading. If these two were shorted to each other, then I'd got a reading. Depending where I'm at, it could be anywhere from 0 to some sort of resistance, depending on what the resistance of the windings are. Or if they were both shorted to the core. That's how you check an isolation transformer, in the same way you check a regular transformer. You've got a power transformer, it's got a primary in it coming out, and maybe a couple of secondaries here that are filament. One may be 5 volt, the other one 6.3, and then you've got your high tension secondary going, normally goes to ground, and then this goes to the rectifier tube. They'll have, something like, a lot of times they'll put on there like 0.2 or 0.1 ohms, and maybe, 200 or 200, say 30 ohms here, and say about the same here, and maybe, something like 4, maybe to 8 ohms here. And, you measure all that. But the other measurement you want to make is from here to here, from here to here, from here to here, and from here to here, to the core. The core is is what gets bolted to the chassis, so you don't want a ground here, as long as that ground's disconnected. If you do this, if that ground is still connected onto the chassis, then you'll probably get a read. But you don't want anything here. Now, sometimes the 6.3 might go to ground too, so you got to be careful with that. But the big thing is you're also going to be checking a lot of the windings, and it's best to disconnect the transformer completely if you suspect any potential shorts, and check it to the core. Well, we did the same thing here. When I'm checking the ground on here, that's checking to the core, because that connects to the core in here. But that's the way, and the proper way, and really the only real proper true test. Now, you can use a light like I did, which will load the circuit and show that, if the light don't light, then things should be okay. But if you really want to know, take your DBM and use it. Use 7 ohms and check both sides, from this side to this side. If it's just a simple transformer where you just got one plug and the cord, well, then just go from the cord to the plug, cord to plug, and then check ground. But that's all you got to do, and that'll tell you if it's reading 0 ohms throughout, that transformer's fine, and you're good to go and perfectly safe. But if you check voltage from that chassis to your line, your outlet, house outlet, especially with 10 meg input impedance, it's going to show up. It's going to show some value of voltage. In fact, if you take one of these little neon guys, it'll dim, but it will light dimly. But the way you know it's not working right is if you plug this on both sides of AC, like right here, then it'll get really bright. So the only real good test is an ohm meter, and to check for anything. And use the ohm meter, don't use the continuity tester, because if there's a short, and wherever you're hooking onto, it's in such a way somewhere in the mid points of the windings, there could be enough resistance the continuity tester won't pick it up. So so don't do that. Use the ohmage, and it should be completely out of limits. You know, where this was showing OL out of limits, there's nothing there. So if you're reading any resistance, you know, a few hundred ohms, a few tens of ohms, or even 0 ohms, or you know, some sort of you know, 1 or 2 or 5 or whatever, anything other than out of limit, or whatever your meter calls when it's way too high of resistance for it to check, you know, it's basically fully open, there's nothing there. Whatever it reads, that's what you should be reading. So use the ohmmeter to test the isolation transformer from one side of the transformer to the other side of the transformer, and as long as that thing is reading, you know, out of limits, which most digital meters, OL is out of limits, means it's outside the limits of the meter's ability to read. So in a case like this, I think this thing can read up to a few hundred megohms, or a few tens of megohms, like 10, 20 megohms or so. It's getting up there where it can't read it. It's beyond that scale. So, which means basically it's not shorted. If it was shorted, it would read just somewhere from the winding resistance down. So whatever that may be, it would read from that down. So I hope that helps and stuff, and I hope that answers the question on it and stuff, and so I want to thank you for watching. If you have any questions, leave them in the comments and we can go over it again or discuss it more and stuff. So, but again, thanks for watching, and I'll see you guys on the next video. Have a good day.